Okay, we'll look at some of the homework problems in section 2.2, where you ask which of these sets can be placed in a one-to-one correspondence. Now keep in mind, in a one-to-one correspondence, that means each element of one set has to be paired with each element of a second set, with nothing left over in either one of those sets. So in part A, can the set 1, 2, 3, 4, 5 and the set MD, MNODR be placed in a one-to-one correspondence? If you look at this, 1 can be placed with M, 2 can be placed with N, 3 can be placed with O, 4 can be paired with D, and 5 can be paired with R. So here, yes, this could be placed in a one-to-one correspondence. Okay. Take a look at part B. Can this set DT, DRLM, and DTW be placed in a one-to-one correspondence? Now, D can be paired with D, R can be paired with T, L can be paired with W, but M, we're going to have problems trying to pair that with something out of this other set. And notice that the sets does not have the same number of elements in each one of those. This one has 4 elements in the first one, the other one has 3, so this one would not be able to be placed in a one-to-one correspondence. Now let's look at C. Can A, B, C, and so on up to F, and the set 3, 6, 9, and so on up to 15 can be placed in a one-to-one correspondence? Now, this is what that first set looks like actually. And the second set is this. Notice you got 6 elements in this set of letters, and this one you have 5 elements in this set of numbers here. Obviously, those numbers, the number of elements in the first set is not the same as the number of elements in the second set, so we do not have a way that these two sets that can be placed in a one-to-one correspondence, so the answer there would be no. Alright, part D. This first set is a set of all T's, such that T is a letter in the word jar. And the second set is 1, 2, 3, 4. Again, now, in the word jar, it's just J, A, and R. And notice that the number of elements here is not the same as the number of elements in this set. So here, this will not be able to be placed in a one-to-one correspondence. And the last one, where we have a rectangle and a triangle, and then the set DR, that can be placed in a one-to-one correspondence because I compare the rectangle with the D and the triangle with the R. So here, that answer would be yes. Okay, take a look at problem number 2. Here's another problem where you have a one-to-one correspondence. Let's say 1, 2, 3, 4, 5, and then MNOAR. Of course, that can be placed in a one-to-one correspondence because we have the same number of elements in each set. The second one, where you have ARLM and ATW. Unfortunately, this will not be placed in a one-to-one correspondence because the number of elements here is different from the number of elements here. And for this one, A, B, C, F, and then 1, 2, 3, 4, 5. Well, A, B, C, and then I'm going to add D, E, and then F, and then 1, 2, 3, 4, 5. We got 6 elements here and only 5 elements here. So no, this would not be placed in a one-to-one correspondence. And then part D, T is a letter in T, such that T is a letter in the word can. It's only 3 letters here, and this one has 4. 1, 2, 3, 4. Again, that can't be placed in a one-to-one correspondence. And then this one, it can be, because the rectangle can be paired with A and the triangle can be paired with R. So that's a yes there. Okay. Number 3. List the elements in the set of all letters in the word true. Okay. Just simply listing each letter in that word true individually. T, R, U, and E. And that's all there is to it. Okay. Now problem number 4 deals with determining which pairs are equal. So here you got A, B, C, D, E, F, G, H, and J. And you want to determine in part A that A is equal to C, true or false. Well, let's look at A and let's look at C. For two sets to be equal, the elements in both A and C must be the same. Here you've got C, E, J, K, and J, K, E, and C. The order is different, but we do have the exact same elements in A and C. So here, this will be true. All right, and then number 2, part B, E is equal to F. Take a look at E. That's the empty set. F has the empty set as an element. That means with the braces around the empty set, that means that there is something in that set. These two are not the same. So here, this will be false. Then part C, C is equal to D. Here's C and here's D. That's false because these two have totally different elements. C has letters as its elements and D has numbers in it. So this will be false. And then part D, E is equal to J. E is the empty set. J has its braces with nothing in it. Those two represent the same thing. They both represent the empty set. So here, that would be true. And then for part E, G is equal to H. Here's G, which is 3, 7, and H is 7, 3. They're equal because they both have the exact same elements in each of those sets. So here, G is equal to H would be true. And then A is equal to B. Take a look. Here's A and here's B. They have the same number of elements, but these elements are not the same in A as it is in B. They're totally different. So here, A is equal to B would be false. All right, problem number 5. List the elements in the set of all letters in the word 0. Well, pretty much that'd be Z, and then E, then R, and then O. And that's all there is to it. Let's listen to each letter in the word 0 individually. And then finally, number 6 is determining whether each of the following is true or false. In part A, 1 is an element of the set 1, 10, 17. That is true because 1 is in that set, as you can see. Part B, 0 is an element of the empty set. That would be false because the empty set has no elements in common or nothing in that set. So that would be a false statement. Part C, 1 is not an element of 1. Actually, it is because 1 is in that set. So that would be false. And then is 10 an element of 10, a true or false statement? In this case, it would actually be true because 10 is an element in that set. Okay. So here, this should be enough to help you do some of the MyMathLab homework problems for Section 2.2.